Hey Neil, how's that I2C driver coming along?
So there I was at work, stuck having to support a custom piece of hardware with multiple I2C devices with nothing but the data sheets to go by. No actual hardware to test it against. So what I figured out was I could use an Arduino, set it up to emulate multiple I2C devices, and then be able to have most of the code working by the time the custom hardware showed up. So if you'd like to see how I do it, stick around. To build the Arduino I2C Multi-Device Emulator, I used two Arduino boards with their I2C, that is the SDA and SCL lines, wired together. One board plays the role of the project's main board that is in reality a several $1,000 evaluation board running an embedded RTOS, while the other board will become our multi-device emulator. Mounting the boards on top of one another prevents wire strain and ensures they don't get disconnected during testing. In order to work with both the master and slave Arduinos at the same time, I've opened up the Arduino projects side by side and set each one to the board's respective serial ports. We begin with the stock wire examples of master writer on the left and slave receiver on the right. Now we just load them up on each board and show that we have basic communications working. This basic demonstration has the master beginning transmission, writing out X is and a space, and then the actual value of X, which is a byte, that is incremented each time it goes through the loop. As you can see, this is received on the serial port in the receive event, and then while there is characters to read, more than one, we read each byte, print them out, and print out the final byte as an actual byte value rather than a character. Let's add another byte value of Y, do the same transmission of Y and increment, except this time we're going to do it to address 9. And of course we have to say that it is Y that we're interested in sending. So now if we recompile and upload this, you'll see that our X has started over at 0, but we're not getting the Y message. And the reason we're not getting the Y message is because we're sending it to a different address. Address 9 instead of 8. Up here on the receiver we said begin at address 8. So now this device is a singular I2C device on one address. The key to emulating multiple devices is the I2C 2-wire address mask register, which we can reach using the macro TWAMR for 2-wire address mask register. What this does is every bit in the address mask register that's 1 will also be considered a matching address. So if we change this to equal, and we'll do it in binary so it's rather obvious. Now the least significant bit is the send and receive bit. So now if we add a 1 here and rerun the slave side, we're now receiving both X and Y messages that were sent to both address 8 and 9. Now a better way to show how the address mask register affects the addresses that we will be considered being sent to us as the slave is to use the stock I2C wire example of the I2C scanner. What the stock I2C scanner does is it looks for every device, it pings every device on the net and prints out the addresses of those that it finds. So if we run this right now, you'll see that it finds devices at both 8 and 9. And on the receiver side, we're getting -1s, which is the result of it scanning the master scanning the bus. So now if we want to see what adding another bit to the address mask register does, we simply change the bit, reload it, and you'll see now we're getting 8, 9, A, and B. We'll do it one more time, add one more bit to the address mask register. Now you're seeing we're getting 8, 9, A, B, C, D, E, F. So no doubt you've guessed where this is heading. If we set all the bits in the register to 1, leaving the least significant bit for the send receive bit, you'll see that according to the scanner, we actually now have every possible address. almost every possible address. We don't have 0 and we don't have 7F. But most of the addresses on the bus that are available in the for an I2C bus are available now. So this is key to how we would make this device respond as if it is multiple other devices on the network. There is a couple of things about this. Having done this, that makes the begin address listed here pretty much irrelevant. So we're just going to set that to 1. You don't want to set that to 0 because 0 is the general call address for I2C, and having more than one device respond when 0 is read from can cause a bus lockup. Unfortunately, this does present a problem when receiving a message because we no longer know on this receive event which address it was intended to be sent to. And I've looked all over the 2-wire interface on the Arduino ATmega 328 datasheet, and it appears that once an address match is made, the address itself is discarded. The workaround for this that I found came from the realization that none of the devices that I'm actually connecting to or going to emulate use a whole lot of data. In fact, they come nowhere near using the whole 32 bytes of data that you can send in one message in the standard wire library. So let's go back over to the master sender, and we'll create a function here to tell the slave what address I'm going to talk to next, and therefore what address it should be acting like. So we're going to do void set slave address and a byte for the address itself. Then we're going to do this whole transmission step again up here, but since it doesn't really matter what device we're transmitting to, we're going to use 1, and we want to send a long message containing all 32 bytes. So there's a couple of different ways of doing that. The easiest way is just with the for loop. I less than 32, I plith plith. And then we're going to wire write our new address and in transmission. So now when we say set slave address of a new address, it's going to be a message of 32 bytes containing the address over and over again. And then over here, we're going to take advantage of the fact that the actual address in the 2-wire interface is pretty irrelevant now, and we're going to use that to store our temporary address. So here in the receive event, when we have how many is 32, we know that we're trying to set the new address. Just copy this for loop from the transmit side over to the receive side. Pretty it up a little here, go from wire read to wire write, and what we want to do is just set the 2-wire address register to the value that we read, and then when we're done reading it all, we just need to shift it over 1 bit so that it is marked appropriately as the address. So now, anytime we send 32 bytes full of an address character, we use it to change the 2-wire address of the receiver. And that is the basic methodology that we were using, although with a whole lot more devices. So here we're about to transmit to 8, so we have to say set slave address to 8. Copy that down to here, say set slave address 9, and then over on this, cancel that. Over on this side, we're going to want to do something different for address 8 than we did for address 9. So we'll keep this for address 8, and we'll say if the 2-wire address register right shifted 1 equals 8, then we're going to do this. And let's see, we will add a little bit more to it. Let's say 0.print from 8 colon. Make sure that's in quotes, of course. And of course, we'll see what it is because we're sending x is to 8 and y is to 9. I'm going to copy that while I'm at it. Then we're going to say if TWAR left shifted 1 equals 9. Then we're going to do basically the same thing over again. All right. except we're going to say from 9. I believe we've got that working. Let's let it run. We'll update the master. Update the slave. Something doesn't look right. Let's see. We've repeatedly read all of those. In fact, to make this a little more general purpose, let's just say while high mini minus minus. So that should make sure we drain all of those. That's what I think these squares are. But that should drain all of them. Put that in there properly. And, oh, of course, if that's all we do here, right? That's all we want to do. So after we do the how many, let's just return out of that so that we're not printing all of the address bytes. So update the slave. Clear the terminal. Make sure master is updated. Oops. I do the left shift equals on that. Update the slave. There we go. Now you see we're getting from 9, from 8. Doesn't look like we're doing our print line like we should though. Oh, let's not do that there in the while loop. Let's do that above the while loop in each case. Update yet again. There we go. So from 8, x is 1. From 9, y is 5. And there you have it. So while this method works with the out-of-box wire library, I should be able to modify the wire library to provide the address that we were actually sending the message to. So comment down below to let me know if you'd like to see a video on creating your own Arduino libraries while we modify the wire library so that we can actually make the receive event not just return how many, but return the address that it was sent to. We may be able to do that. I may not. So that's the basics of being able to emulate multiple devices using a single Arduino. From here, you can enhance this logic in a number of different ways and to emulate different devices. And to do that, you'd have to dig into their data sheets. Thanks for watching. Be sure to like, subscribe, and ring the bell for notifications, and we'll see you in the next one.